Hi guys, today we will discuss about the transpose of a matrix. We have described like what is a matrix and how to do different operations on matrix, different properties of matrix, addition, subtraction, multiplication, etc. Today we will do about the transpose of matrix, and then we will discuss about some properties of transpose of matrix, and after that we will go through one or two simple problems so that the transpose of matrix is if people can understand very easily. And transpose generally in the joint entrance examination in or in other examination, a few questions come directly or indirectly from transpose of matrix. Like sometimes they give you the equations where you have to do transpose of matrix, and then you have to do the normal inverse or some other operations. Okay, so this is very important. And so that's the basic concept. What is a transpose of matrix? The transpose of matrix is defined by another matrix in which the place of rows is interchanged by the place of columns. Basically, let's say you are having one matrix, and then that matrix is having m cross n order, that is m number of rows and n number of columns. Now it will be just opposite. Opposite means the columns and rows will be interchanged. So that is a transpose of a matrix. Like the columns will be put in the place of rows and rows will be put in the place of columns. So the element like aij, generally we consider the elements of a matrix. So that element aij will be converted to aji in the transpose of a matrix. Let us suppose that P is a matrix and then its transpose of matrix is denoted by T. Capital T means transpose, and generally it is represented as P to the power T, like the matrix, then to the power T. T means transpose. So like let's say if P is have a matrix of order m cross n, then transpose will be transpose of the matrix, then its order will be n cross m, just the opposite, reverse basically. So let's take an example, then it will be clear. Let's say P equal to one matrix, that is a 3 cross 3 matrix, because it is having 3 rows and 3 columns. LMN first row, OPQ second row, and RST third row. Similarly, LOR first column, MPS second column, and NQT is the third column. So this is a matrix. Now I will do the transpose of the matrix. What will be the transpose of the matrix? As it is a 3 cross 3 matrix, so the transpose will be also be 3 cross 3 matrix. Just what will happen? The number of elements of the rows will be interchanged with the number of elements of the columns. So how the interchanging happens? Let's see. So let's say L. L is A11. So A11 will be A11, no problem. Then it's M. M means A12. First column, first row, second column. So it will be here. So basically LMN here in the row, that will come in the column. OPQ in the row, that will come as a column. RST in a row, RST will come as a column. So this is basically the transpose of a matrix. The concept is clear now. Now let's go ahead with some of the properties of transpose of matrix, and then we will go through one example, one or two examples of transpose of a matrix. So what are the different properties of transpose of matrix? Let's see. Let us assume that P and Q be the two matrices and A and B be the two real scalars. So if transpose of a transpose matrix is calculated, then it will be equal to the original matrix. That means, let's say P to the power T, P means original matrix. So P to the power T means transpose of P, and then again I am taking a transpose, so it will come to the original matrix. Second property, transpose of scalar multiplication to a matrix is irrelevant to the order. Like if we do the scalar multiplication, it will be just like that, like A P whole to the power T, T means transpose of a matrix, equal to A outside, then P to the power T, like it is same. The transpose of the sum or difference of two matrices is equal to the sum or difference of the transpose of both matrices separately. Like let's say P and Q are two matrix, so P plus Q, if I do matrix addition operation, then whole to the power transpose, like the additive matrix, if I do a transpose, then it will be something like the transpose of the individual matrices and addition, like P to the power T plus Q to the power T. You have to remember these things, because in the joint entrance examination sometimes these things are coming as a number one for the number one problems, or sometimes these rules we have to use in the other problems to derive something. And P minus Q, and similar thing happen with the subtraction also. So P minus Q whole to the power T equal to P to the power T minus Q to the power T. Fourth property, the transpose matrix of the product of two matrices equal to the transpose product of in reverse order. It is very important. Like let's say P and Q are two matrices, then PQ whole to the power T, like product and then transpose, equal to Q to the power T into P to the power T. That is something which is a little bit tricky. You have to remember. For a square matrix, the determinant is equal to the determinants of its transpose, that is determinant of transpose matrix equal to determinants of the same original matrix. The transpose of inverse of a matrix is same as the inverse of transpose of that matrix, like P to the power T. P is the original matrix. If I do a transpose, that is P to the power T, then if I take the inverse, equal to P inverse to the power T. Different formulas associated with different rules associated with transpose of matrix. Let's move ahead with one example of transpose of matrix that will help you. Example 1. Find the transpose of the following matrix. First matrix 4 minus 1 0 5 2 9. Second matrix 9 6 1 5 7 8. For the first matrix, you can see what is the order. The order of the matrix is, number of rows is 1 and 2, number of column 1 2 and 3. So m equal to 2 and n equal to 3. It is a 2 cross 3 matrix. So the transpose of the matrix will be 3 cross 2 matrix, just the reverse. So let's see how the solution is done. A equal to this, then A transpose equal to just the row. What is the row? 4 minus 1 0. So this 4 minus 1 0 will be a column. So 4 minus 1 0 is the first column. 5 to 9 is the second row. So 5 to 9 will come as a second column. 5 to 9 will come as a second column. So now the matrix is 3 cross 2. The 3 row 1, 2 and 3 and 2 column 1 and 2. So this is the transpose of matrix. Let's go ahead with another example. Second one, 9 6 1 5 and 7 8. So you can see what is the order of the matrix. First row 1, row 2 and row 3. So 3 rows, column 1 and column 2. So 2 columns. So it is a 3 cross 2 matrix. So the transpose of the matrix will be 2 cross 3 matrix. So this 9 1 7 is the 9 6 is the first row. So 9 6 will be the first column. So 9 6 9 6 9 6. 1 5 is the second row. 1 5 will be the second column. 7 8 is the third row. 7 8 will be the third column. So that's all. Let's move ahead with another example. If P equal to one matrix and Q equal to another matrix, then prove the identity P plus Q whole to the power T equal to P to the power T plus Q to the power T. That is basically one of the rules which we have described in our earlier slide. So here we will prove with one example. Okay, so it is very easy. So what I can do P plus Q operation first. Okay, what will be my P plus Q operation? P plus Q means P is 3 6 1 minus 4 and Q equal to minus 1 4 5 8. So if I do P plus Q, then this 3 will be added with minus 1, 6 will be added with 4, 1 will be added with 5 and minus 4 will be added with 8. So 3 minus 1, 6 plus 4, 1 plus 5 minus 4 plus 8. It becomes 2, 10, 6 and 4. Okay. So if I take a transpose, that is p plus q whole to the power t, the rows will be column and column will be rows. So 210 is the first row, 64 is the second row. So 212 will be my first column, 210, and 64 the second row will be second column, that is 64. So I know what is my p plus q whole to the power t. Now I will find out individually the p to the power t and q to the power t. So p equal to 3 6 1 minus 4. So p to the power t equal to 3 6 will be as the first row, that will be first column. So 3 6 1 minus 4, that 1 minus 4 will be the second column. For q, minus 1 4 5 8, minus 1 4 is the first row, so minus 1 4 will be the first column, and 5 8 is the second row, so 5 8 will be the second column. So I will add p to the power t plus q to the power t. So if I add p to the power t plus q to the power t, it will be 3 minus 1, 1 plus 5, 6 plus 4, minus 4 plus 8. So equal to 2 6 and 10 4. So that is also a, so 2 6 10 4 already we have found out p plus q whole to the power t. So these things and these things are equal, so my identity is proved. So these are the theory and example of transpose of matrix. I think that's it, and thank you for watching the video. This was a very simple concept. Now next we will go through different matrix terminology and problems and solutions. So thanks for watching my video. If you like in the YouTube, and subscribe me so that this video can be reached to wider audience. Thank you. Have a good day.